Welcome, guys. In this clinic, we are going to do an example on how to find errors in function of several variables following the derivation we did in the previous presentation. So I encourage you to check the previous video on the derivation of the general error formula in functions of several variables so that the example makes sense to you. My name is Vincent. I lecture at University of Nairobi School of Mathematics. So here are the problem. So I've been given that S is a function defined by three variables, A, B, and C. So the function is defined as S equals to A squared square root of B over C cubed. A is 6.54 plus or minus 0.01. B is 48.64 plus or minus 0.02. And C is 13.5 plus or minus 0.03. So there are four problems for us to work out. First is to find the exact value of S. That one is very obvious. It's not very hard. Then the error in S, the relative error in S, and then the percentage error in S. Good. So remember, when you are given values like what you have in A, B, and C, then to work out the first problem, remember that this is a value that you pick, then these are the errors. So error in A is given by 0.01. Error in B is given by 0.02. And then error in C is given by 0.03. That's the first thing that you need to note. And then the values we pick as the true values for A, B, and C are these values given the first numbers. So therefore, the first part, solution, S, which is given by A squared square root of B over C cubed, is simply given by, where there's A, we put 6.54 and then square. Square root of B is 48.64. And then C is 13.5 raised power 3. And then you put these values in your calculator. So we'll have 6.54 squared times square root of 48.64 divided by 13.5 power 3. The answer is 0.121241408. That is what we get as the answer to the first part. Now the second part is to find the error in S. Now here, note that S is a function of three variables, A, B, and C. So therefore, if you remember the previous presentation, the error in S will be given by error in A times partial S partial A plus error in B partial S partial B plus error in C partial S partial C. And in case any of these terms we have negative values, then you take the absolute value of that term. So let's get now those derivatives. I remember these values, error in A, error in B, error in C have already been provided, so there's no problem there. So partial S, partial A, this is our S function. So remember, S can just be written as A squared, B power half, and then C power negative 3. This is the same way of writing S. So using partial derivatives, I will have 2A B power half, C power negative 3. And then partial S, partial B will be given by a half A squared, B power minus a half, C raised power minus 3, and then partial S, partial C will be given by minus 3 A squared, B power half, and then that is C raised power minus 4. So replacing this value, let me call this formula star. So we'll have error in S will be given by now error in A with 0.01 times partial S partial A we have times 2A B power a half and say over C power 3 plus error in B 0.02 times a half and then A squared B power negative a half over C power 3 and then plus minus 0.03 times 3 A squared B power half over C power 4. But then now, because there's a negative here, negatives here, then we take the absolute value of this term. So just put this. So that error in S will be given by, so this will be 0.02 times A is 6.54 and then B is 48.64 raised to a half divided by C is 13.5 power 3 and then plus this other term, so this will be 0.01 times A, which is 6.54 power 2, B is 48.64 power negative a half, divided by C, which is 13.5 power 3. And then plus absolute value of, so this will be negative 0.09 times A, which is 6.54 power 2, B, which is 48.64 power a half, and then over C, which is 13.5 raised power 4. So error in S will be, when you calculate the first term, we get 3.707688344 times 10 raised to negative 4. Confirm this value. Plus the second term will give us 2.4926 and then 7649 times 10 raised to negative 5 plus the absolute value of this one now get positive will be 8.082766059 times 10 raised power negative 4. Now, when you put all these values together, you get that error in S will be given by 1.20 and then 3971658 times 10 raised power negative 3. So that is Roman 2. Roman 3, they want us to find the relative error in S. And by definition, relative error is given by error in the function over the true value of the function, which will be given by 1.203971,658 times 10 raised power negative 3 over the true value of the function from what we calculated in the first part. We have 0.121241408. And when you carry out this division, you get 0.00993036 and then 774. So this is Roman 3. A Roman 4 percentage error in S is simply given by relative error in S multiplied by 100%. So relative error we have in Roman 3, 0.009930366774 times 100%. So this will give us 20. So we have 0.9930366 0.774%. So therefore, this is the solution to the last part of that given problem. So quickly, another one, if we are given, this is problem number 2, given that we have another function u given by 5x y squared over z power 3, and then x equals to y equals to z equals to 1, with error in x equals to error in y equals to error in z equals to 0.001, find error in u. And then, so this first part, and then relative error in u, and then percentage error in u. So this is another interesting problem. So the first thing is that we have to find the value of the function first. So value of u, remember u is a function of 3 variables, x, y, and z, given by 5x y squared, then I can say z is power minus 3. So error in u is given by error in x times partial u partial x plus error in y partial u partial y plus error in z partial u partial z. And in case any of these terms has negative sign, then you take the absolute value. So error in u is 0. So let's just find partial u partial x. From this one, we'll have 5y squared z minus 3, and which means that partial u partial x at x equals to y equals to z equals to 1 will give us 1 squared 1 minus 3, which will give us 5. And then partial u partial y will be given by, so this one will be 10x y z minus 3, which means that partial u partial y at x equals to y equals to z equals to 1 will be 10 1 1 1 minus 3, which will be 10, and then partial u partial z, from this one we'll get minus 15 x y squared z minus 4, which means that partial u partial z at the point x equals to y equals to z equals to 1 will be minus 15 into 1 squared 1 minus 4. This will give us minus 15. So therefore, error in u will be absolute of error in a partial u partial a partial error in x partial u partial x plus absolute error in y partial u partial y plus absolute error in z partial u partial z. So everything error in x, error in y, all of them are 0.01. So error in u will be absolute of 0.001 times value of this one we have gotten it to be 5 plus 0.001 times 10 plus 0.001 times minus 15. So error in u will be, so this will be 0.005 plus this will be 0.01. Then this now be plus 0.015. So 0.001 times 15. Yeah, that's correct. So when we add all this one, 0.05, 05 plus 0.01 plus 0.015, we get 0.03. So this is the error in U. Part 2, they want us to find the relative error in U. And remember, by definition, this is error in U over U. So let's first calculate the value of U, which is given by 5xy squared over z power 3, which is the same as 5, x is 1, y is 1, and then z is also 1. So this just gives us 5. So therefore, relative error in U will be error in U, which is 0.03 over U, which is 5. And then this gives us 0.006. Lastly, percentage error in U would be simply given by relative error in U times 100%. And from 2, you already have relative error in U 0.006 times 100% gives us 0.6%. So therefore, this is the solution to the last part of that problem. So that is how we find error in function of several variables. Remember, if any of the terms in the function involves trigonometric part, then the mode of your calculator must be in radians for you to get the correct answer. And whenever any of the derivatives of any of the term in the error definition is negative, then take the absolute value of that term to define the error. So thank you.